So once again, here is another scenario that we can't just apply our table of derivatives and come up with the answer. And it's a common occurrence in mathematics where you've got two functions multiplied together. So if you like, we've got g of x times h of x. So here g of x would be 5x to the fourth minus 3x, and my h of x is equal to sine x. Now notice that this is not a chain rule type question. It's quite different because we've got two very different functions multiplied by each other, and that's always we use it. We call it the product rule because it's the product of two functions. And we've got to come up with dy dx. We've got to find dy dx. So what we do is we let u, just like we did with the chain rule, we let u be one of the functions and we let v be the other function. So in this case, and it doesn't matter which one you let u equal to and which one you let v equal to. So I could let u equal sine x, but I'll just go left to right. So u is equal to 5x to the fourth minus 3x. So we've got du dx. And that is using our table 20x cubed, so 4 times 5, and take 1 off the power, minus, now derivative of something x is just the something, so it'll be just minus 3. Okay, so that's du dx. V is equal to sine x, and from our table of derivatives, dv dx is equal to cos x. Now the product rule, which you need to remember, says that dy dx equals u dv dx plus v du dx. That's the product rule, one you should remember. And now it's simply a matter of just doing the substitute in. So sometimes it's good if you set it out like that, you just put a cross through there, and that's to remind you that you're going to multiply the two. It's always plus in the middle here. And so we're going to multiply along that first arm. So it'll be, and once again, we probably need to put this in brackets, times cos x plus, this is this plus here in the middle, v sine x times 20x cubed minus 3. Now that doesn't look like we're going to be able to simplify that too much, so there's no point in multiplying things out and trying to collect like terms in this situation. It's just probably best to leave it as it is. So that's the product rule. That's the answer. It's not particularly difficult. Sometimes to remember the rule, it is quite okay. Instead of writing dy du, we say y dash. Sorry, this should be dy dx, shouldn't it? Dy dx is equal to u dv dx. So that's the product rule. So instead of dy dx, we write y dash is equal to u times, now dv dx is just v dash plus v, and this is du dx. Notice they're all dx's, and that's how I picked up my mistake there. So du dx would be u dash. Now that may, for some people, be a better way of remembering the product rule. It's always plus between the two. Dy dx is equal to u dv dx plus v du dx. Okay, so maybe do one more example. Y equals, let's go ln, let's go 15x ln 4x squared. Okay, so if you like, we've got two functions multiplied together. So we'll use this version of the product rule, y dash equals uv dash plus vu dash. So we've got u equals 15x, so u dash would be equal to 15, u dash standing for du dx, and v equals ln of 4x squared. Now be very careful here. V dash, we have a chain rule situation here because this 4x squared is a function in itself, and then we're finding the log, which is the second function. So we're going to have to apply the chain rule here. Now, the shortcut we learned was that the derivative, we diff in first. Now, diffing in is finding the derivative of 4x squared, and that is 8x times the derivative of ln of 4x squared. Now, the derivative of ln is 1 over, and what's its ln of? 4x squared. And a little minus sign up there, came from somewhere. And if it's possible to cancel at this stage, this is v dash. We can cancel the 4 and x, and that'll be the power of 1. So we get 2 over x. So that's v dash. Now we can say that y dash, which is dy dx, is equal to, quote the rule, write it out each time you do one of these, that way you remember it, plus v u dash, and that's equal to u is equal to 15x v dash times 2 over x. So I've multiplied along that arm, always plus in the middle, v ln 4x squared u dash times 15. Now be very careful here too. It's all of that times 15, so sometimes it's good to put those brackets in. Simplify. The x's will cancel out, and we get 2 times 50 is 30, plus that 15 we can put at the front, 15 ln of 4x squared. You could put 15 as a common factor out the front. I don't think there's much mileage in that, so probably just leave it as it is, and there's our answer of dy dx. So dy dx is equal to 30 plus 15 ln natural log of 4x squared.